grade 10 or the intro to applied pre-calc class or your applied 30S class. When I write the equation y equals x plus 1, the solution for that equation is any coordinate that appears on that line. So I start by going to 0 and 1, mark it off. I do what my slope says, which is 1 over 1, so I go up 1, right 1, and then I draw my line through that. So any coordinate on that line satisfies the equation of y equals x plus 1. So if I pick another coordinate, let's say the coordinate I'm going to pick is going to be this one right here, which is -1 and 0. If I put it into that equation, all right, this should equal. So I put 0 in here, -1 in here for x, -1 plus 1, I get 0 is equal to 0. Okay? So that's what the point of an equation is for a line, is it tells you that if you choose any coordinate on that line, it's going to balance that equation off. What we're going to look at is the same idea today, except we're going to look at the inequalities, which then says the solution may be on that line, it may be above that line, or it may be below that line, and then we shade that area. So we've already done this in grade 11 applied, so everybody, of course, except for Brian, has done this, so we just have to go through and we have to remember how to do it. The first thing that you got to remember how to do, which is graphing a line in itself. All right, I love the y-intercept form. Okay, go to the coordinate, the 0 and whatever coordinate, 0b coordinate, and then your slope tells you where to go from there. You might want to put in 0 for x and y and find your intercepts. And graph the one that's on this line and graph the one that's on this line. You might want to just put in x for 2 values for x, solve for y, and then graph your line. Whatever it is that you want to do, graph it whatever way you can. You also have the calculator in which you can graph it. So let's look at the example number 1. It says, graph and label a linear inequality. 4x minus 3y is less than -12. 4x minus 3y is less than -12. So I want you to follow along in your book. Okay? So it says isolate y on the left side of the inequality. So the first thing that I suggest you do is you change the inequality to an equals sign. So I get 4x minus 3y equals -12. Now I'm going to put it into slope-intercept form. Minus 3y equals minus 4x minus 12. Divide by -3. I get y equals 4 over 3x plus 4. Okay? So now I can graph the line. What is my starting coordinate for my line? 0 and 4. Excellent. Where do I go from that coordinate? Gabrielle, where do I go from that coordinate? Up 4 over 3. We'll find some interest in this class, would you? 1, 2, and 3. Okay, now I've got 2 points. I draw the line through. Okay, now remembering back to apply, what do I got to do with this line? What's important that I do? It's a dash, that's right. Okay, because there's no equals to here, none of the solutions are going to be found on that line. Now if it said greater than or equal to, Brian, then I have to put a solid line because those also are parts of the solution. So now what I do is I graph this, like that, there and there. Okay? Now the next order of business is to find out where the solution set falls. And again, the easiest thing to do is if you don't go through the 0 and 0 coordinate, just find out if it satisfies it. So here's 0 and 0 right here. Okay? I'm going to put that in for x and y. You can use any coordinate you want. Again, so I have 0 is less than -12. Is 0 less than -12? Is it?
No.
No. It's greater than negative 12. Therefore, that can't be part of the solution, so it must be everything else that's up here, so a shade above the line. All right, now you can pick any coordinate in here, plug it into that inequality, and it'll be true. Okay? Any questions so far? So again, the first thing that you want to do is be able to put it in a slope-intercept form, and then draw your line. Okay? All right, next one. Can you keep up, then, please?
This is exactly what we did in the 5 pen.
Exactly the same. There's only going to be one change, and that's we're going to do parabolas as well. Other than that, it's exactly the same. So 2x minus 3y is greater than or equal to 15. Okay, so I want to graph that. Change that to an equals. Okay. Does that look right?
Yes.
All right, subtract 2x, divide by negative 3. What's my starting coordinate? Coordinate?
0, negative
0, negative 5, that's right. Where do I go? Up to?
5.
Grade 3. Solid or dashed line? Right? Solid, because I have the equals to, that means that every point on that line also satisfies the inequality. Okay? So I draw it up like this. And then the last step is to find out whether a shade down here or shade up here. So go ahead.
Is there anything like with dots you fill them in? Or is that
Yeah,
something else?
we're not there yet.
Right.
That in fact, we may not have to. Not right away, and that's a good question, Carlton. I'm not sure we will. I don't see it in here right now. Okay, so what Carlton's referring to is the dots is when you had like something that said whole numbers or integers, right? So instead of real numbers, there's whole numbers, but I don't see it in here.
Right.
Okay, so that's good. Good question. Okay, so I'm going to check with this coordinate 0 and 0. Is 0 greater than or equal to 15? No? Again, 0 and 0 is not a part of the solution, so everything below that line must be. Okay? Jay, do you follow this? Okay. Any questions about that? Look at 368 for a second. Which of the ordered pairs are solutions to the given inequality? What are you going to do there? Yeah, and then solve it, right? So you plug each coordinate in for x and y, and tell me whether it's true or false. That's it. Okay? So that's exactly what I'm doing here with the 0 and 0. In each case, it's false, so I don't shade over it because it can't be part of the solution. Fair enough?
Or just graph and look at the graph.
Right?
Or you can just graph and shade.
Well, you still need to know how to shade which one. And so you need a coordinate to tell you whether you shade which. But yeah. Okay? Graphing calculators, you can use them for this as well. All right? And if you remember on your calculator, when you go to y equals, on there, there's a little dash. On your calculator, there's a little dash next to the y on this side. And if you hit it once with the enter sign, it thickens it, which just changes your line. You hit it a second time, it gives you this. Okay? And that's the greater than sign. All right? So it'll shade for you. So let's try this then. Let's go graph this for me. Okay? Graph that on your calculator and change this to this sign right here. All right? Actually, we have an error here. Hold on a second. An important error.
That works.
No, it shaded the wrong side.
Oh,
It should have been
wow.
this. Now I'm going to show you why actually. This we didn't bring up in. We did not bring this up in applied, so I'm going to show you how this works. If I work with this equation right here, and I want to get it into y equals without changing this to an equal sign, there's one really, really important thing you have to pick up. And that's this. I'm going to subtract the 2x. So I get minus 3y is greater than or equal to minus 2x plus 15. Okay, so the same thing, what I just did. I'm going to divide by negative 2. Here's the catch on the whole thing. If I divide by a negative number, I have to move the sign the other direction. Okay? So that becomes that, 2/3 x minus 5. So if I divide or multiply by a negative number, that's what happens. Now I want you to see the alternative as to why that happens. And that's if I decide to move the y instead of the x here, look what happens. 2x greater than or equal to 3y minus 15 or plus 15, right? So look at what happens to the 3y. The mouth is no longer opening to it, it's opening away from it by just adding it to this side. So that's why you have to change it. Okay, so then when you divide by a negative number, you change that inequality. So this is what it should look like. And then you graph it, and it'll shade that area on the graph. So anybody that was not able to do that, grab there.
So that one is less than?
Sorry?
That one is less than?
That one is less than for that one. Yeah. Okay. Any questions about that? All right. So you got to be able to do this with pencil and pen on paper or pencil and paper, I mean. But you can also use your calculator to check your solutions. All right.